Hello everyone, and welcome back to the channel. I am so happy to see you here today. If you are new to this channel, please take a moment to subscribe. Click that subscribe button and hit the notification bell so you do not miss any of our upcoming lessons. If you find this video helpful, please give it a like. It really helps us to reach more students who need this kind of support. Also, I want to hear from you. If you have any problems or topics you're struggling with, please comment down below. I read every single comment. And for those of you who have personal questions or need one-on-one help, I will put my WhatsApp line below the video in the description box. Feel free to message me there. I'm here to help you succeed. Today, we are going to learn about a topic that is fundamental to further mathematics and additional mathematics. We are going to talk about polynomial functions, specifically part 1, which focuses on quadratic functions. This lesson is suitable for SHS1 and SHS2 students. Now, I know that when you hear the words polynomial or quadratic, you might feel a little nervous. Many students find this topic challenging because there are many formulas and steps to remember. But I want you to relax. We are going to take this very slowly. We are not going to rush. We will break everything down into small, easy pieces. By the end of this video, you will understand exactly how to handle these problems. We have about 3 periods worth of content here, which is 120 minutes, so we have plenty of time to explore this deeply. I want this narration to be about 35 to 40 minutes long, so that you have enough time to digest every single step. So grab your notebook, get your pen ready, and let us begin. Let us look at what we want to achieve by the end of this lesson. These are our learning objectives. By the time we finish, you should be able to define a quadratic function and identify its standard form. You will learn how to find the roots of a quadratic equation using a method called completing the square. You will learn how to express a quadratic function in vertex form, which looks like a times open bracket x minus h close bracket squared plus k. You will learn how to determine the line of symmetry, the turning point, and whether the function has a maximum or a minimum value. You will learn how to derive and apply the sum and product of roots formulas. And finally, you will learn how to evaluate symmetric functions of roots, like alpha squared plus beta squared, without solving for the roots individually. That is a lot, but we will take it one piece at a time. Let us start with section 2, Introduction to Quadratic Functions. What is a quadratic function? A quadratic function is a polynomial function of degree 2. This means the highest power of x is 2. Its graph is a curve called a parabola. You have probably seen this shape before. It looks like a U, or an upside-down U. The standard form of a quadratic function is written as f of x equals a x squared plus b, x plus c. Here, a, b, and c are constants. They are just numbers. X is the variable. There is one very important rule. A must not equal 0. If they equal 0, the x squared term disappears and it becomes a linear function, which is just a straight line. We do not want that. We want a quadratic, so it cannot be 0. Now, let us talk about the shape of the graph. This depends on the value of a. If a is greater than 0, meaning a is positive, the parabola opens upwards. It looks like the letter U. It looks like a smile. When it opens upwards, it has a minimum point. This is the lowest point on the graph. If a is less than 0, meaning a is negative, the parabola opens downwards. It looks like an N shape. It looks like a frown. When it opens downwards, it has a maximum point. This is the highest point on the graph. Remember this: positive a is a smile and a minimum. Negative a is a frown and a maximum. Now let us move to section 3, Methods of Finding Roots. The roots, also called zeros, of a quadratic function are the values of x, where f of x equals 0. Graphically, these are the points where the curve crosses the x-axis. When the graph touches the horizontal line, the height is 0. There are three main methods to find these roots. Method 1 is factorization. This is quick, but it only works for simple integers. Sometimes you cannot factorize easily. Method 2 is the quadratic formula. This works for all equations, but you have to memorize the formula. Method 3 is completing the square. This is algebraically rigorous. It reveals the vertex of the parabola. This is the method we are going to focus on today, because it helps us with many other things later. Let us focus on the method of completing the square. This method rewrites the quadratic into a perfect square plus a constant. It is essential for finding the turning point. We will look at case 1. This is when a equals 1. This means the number in front of x squared is just 1. Example 1. Solve x squared plus 6x plus 5 equals 0 by completing the square. Step 1. Move the constant term to the other side. The constant term is the number without an x. Here, it is positive 5. We want to isolate the x terms, so we subtract 5 from both sides. On the left, the 5 cancels out. On the right, 0 minus 5 is negative 5. So we write x squared plus 6x equals negative 5. Step 2. Take half of the coefficient of x, square it, and add to both sides. The coefficient of x is the number in front of x. Here, it is 6. Half of 6 is 3. Now we square this number. 3 squared is 9. We must add this 9 to both sides of the equation to keep it balanced. So we write x squared plus 6. X plus 9 equals negative 5 plus 9. Step 3. Write the left side as a perfect square. The left side is now x squared plus 6x plus 9. This is a perfect square trinomial. It factors into open bracket x plus 3 close bracket squared. On the right side, negative 5 plus 9 equals positive 4. So we write open bracket x plus 3 close bracket squared equals 4. Step 4. Take the square root of both sides. To remove the square, we take the square root on the left. The square root cancels the square, leaving x plus 3. On the right, the square root of 4 is 2. But remember, when we take a square root in an equation, we must consider both positive and negative. So it is plus or minus 2. So we write x plus 3 equals plus or minus 2. Step 5. Solve for x. We have two cases here. Case 1, x plus 3 equals positive 2. Subtract 3 from both sides. X equals 2 minus 3. So x equals negative 1. Case 2, x plus 3 equals negative 2. Subtract 3 from both sides. X equals negative 2 minus 3. So x equals negative 5. The answer is, the roots are x equals negative 1 and x equals negative 5. Please write that down. Take a moment to check your work. Did you get the same answer? This method takes practice, so do not worry if it feels slow at first. Now, let us look at case 2. This is when a is not equal to 1. This means there is a number in front of x squared. Example 2. Solve 2x squared plus 8x plus 3 equals 0 by completing the square. Step 1. Divide the entire equation by a to make the coefficient of x squared equal to 1. Here, ab is 2. So we divide every term by 2. 2x squared divided by 2 is x squared. 8x divided by 2 is 4x. 3 divided by 2 is 3 halves. 0 divided by 2 is 0. So the equation becomes x squared plus 4x plus 3 halves equals 0. Step 2. Move the constant to the right side. The constant is 3 halves. We subtract 3 halves from both sides. So we write x squared plus 4x equals negative 3 halves. Step 3. Add the square of half the coefficient of x to both sides. The coefficient of x is 4. Half of 4 is 2. 2 squared is 4. We add 4 to both sides. So we write x squared plus 4x plus 4 equals negative 3 halves plus 4. Step 4. Simplify and write as a perfect square. The left side is x squared plus 4x plus 4. This factors in the open bracket x plus 2 close bracket squared. On the right side, we have negative 3 halves plus 4. To add these, we need a common denominator. 4 is the same as 8 halves. So negative 3 halves plus 8 halves equals 5 halves. So we write open bracket x plus 2 close bracket squared equals 5 halves. Step 5. Take the square root. X plus 2 equals plus or minus the square root of 5 halves. To solve for x, subtract 2 from both sides. X equals negative 2 plus or minus the square root of 5 halves. If you calculate this, the square root of 2.5 is approximately 1.58. So x is approximately negative 2 plus 1.58, which is negative 0.42. Or x is approximately negative 2 minus 1.58, which is negative 3.58. The answer is x equals negative 2 plus or minus the square root of 2.5. This looks complicated, but you have done it correctly. The key was dividing by a first. Never forget that step when a is not 1. Now let us move to section 4, turning points in line of symmetry. We have something called vertex form. By completing the square on the general form ax squared plus bx plus c, we can rewrite any quadratic as f of x equals a times open bracket x minus h close bracket squared plus k. Here, open bracket h, k close bracket is the turning point, also called the vertex. This is the highest or lowest point of the parabola. How do we find the turning point? There is a formula for the line of symmetry. This is the vertical line that cuts the parabola in half. The formula is x equals h equals negative b divided by 2a. The maximum or minimum value is the y-coordinate of the vertex. The formula is y equals k equals f of open bracket negative b divided by 2 a close bracket. This means you find the x value first, then plug it back into the function to find y. Let us look at example 3. Find the turning point. Find the coordinates of the turning point for f of x equals 2x squared minus 8x plus 5. We will use method A first. This is using the formula. Step 1. Identify A, B, and C. A is 2. B is negative 8. C is 5. Be careful with the signs. B is negative here. Step 2. Find the x-coordinate. This is the line of symmetry. X equals negative b divided by 2a. Negative b means negative of negative 8, which is positive 8. 2a means 2 times 2, which is 4. So x equals 8 divided by 4. X equals 2. Step 3, find the y-coordinate. Substitute x equals 2 into the function. Y equals 2 times open bracket, 2 close bracket, squared minus 8 times 2 plus 5. 2 squared is 4. 2 times 4 is 8. 8 times 2 is 16. So a equals 8 minus 16 plus 5. 8 minus 16 is negative 8. Negative 8 plus 5 is negative 3. So the turning point is open bracket 2, negative 3 close bracket. Nature, since a equals 2, which is greater than 0, this is a minimum point. Remember, positive a is a smile, so it has a minimum. Now let us use method B. This is completing the square. Step 1. Factor out a from the x terms. F of x equals 2 times open bracket x squared minus 4, x close bracket plus 5. We only factor out from the x terms, not the constant 5. Yes. Step 2. Complete the square inside the bracket. Look at x squared minus 4x. Half of negative 4 is negative 2. Square of negative 2 is 4. We add and subtract 4 inside the bracket to keep it balanced. F of x equals 2 times open bracket. x squared minus 4x plus 4 minus 4, close bracket, plus 5. Step 3, simplify. The first three terms inside become open bracket x minus 2, close bracket squared. So f of x equals 2 times open bracket x minus 2, close bracket squared minus 4, close bracket plus 5. Now multiply the outer 2 by the inner terms. 2 times open bracket x minus 2, close bracket squared is 2 open bracket x minus 2, close bracket squared. 2 times negative 4 is negative 8. So f of x equals 2 open bracket x minus 2 close bracket squared minus 8 plus 5. Minus 8 plus 5 is negative 3. So f of x equals 2 open bracket x minus 2 close bracket squared minus 3. Compare this with the times open bracket x minus h close bracket squared plus k. A is 2, k is negative 3. So the turning point is open bracket 2. Negative 3 close bracket. Both methods give the same answer. Method A is faster, but method B shows you the structure. Now, let us move to section 5, sum and product of roots. This is also called symmetric functions. Let the roots of the quadratic equation a-lun. X squared plus bx plus c equals 0. Be alpha and beta. Alpha and beta are just names for the two solutions we found earlier. We can derive formulas for them. If alpha and beta are roots, the equation can be written as a times open bracket x minus alpha close bracket times open bracket x minus beta close bracket equals 0. If we expand this, we get a times open bracket x squared minus alpha x minus beta x plus alpha beta close bracket equals 0. This simplifies to a x squared minus a times open bracket alpha plus beta close bracket x plus a alpha beta equals 0. Now compare this with the standard form, ax squared plus bx plus c equals 0. Look at the coefficient of x. In the expanded form, it is negative a times open bracket alpha plus beta close bracket. In the standard form, it is b. So negative a times open bracket alpha plus beta close bracket equals b. Divide by negative a. Alpha plus beta equals negative b divided by a. This is the sum of roots. Look at the constant term. In the expanded form, it is a alpha beta. In the standard form, it is c. So a alpha beta equals c. Divide by a. Alpha beta equals c divided by a. This is the product of roots. Here are the key formulas you must memorize. Sum of roots, alpha plus beta equals negative b divided by a. Product of roots. Alpha beta equals c divided by a. Why do we use this? You can find complex expressions involving roots without solving for alpha and beta individually. This saves time in exams. Here are some identities. Identity 1. Sum of squares. Alpha squared plus beta squared equals open bracket alpha plus beta close bracket squared minus 2 alpha beta. Identity 2. Sum of reciprocals. 1 over alpha plus 1 over beta equals open bracket alpha plus beta close bracket divided by alpha beta. Identity 3. Difference of roots. Open bracket alpha minus beta close bracket squared equals open bracket alpha plus beta close bracket squared minus 4 alpha beta. Let us look at example 4. Using sum and product, given that alpha and beta are the roots of 2x squared minus 5x plus 3 equals 0. Find the value of 1. Alpha plus beta. 2. Alpha beta. 3. Alpha squared plus beta squared. Solution. First, identify A, B, and C. A is 2, B is negative 5. C is 3. 1. Sum of roots. Alpha plus beta equals negative b divided by a. Negative b is negative of negative 5, which is positive 5. A is 2. So alpha plus beta equals 5/2. 2. Product of roots. Alpha beta equals c divided by a. C is 3, a is 2. So alpha beta equals 3/2. 3. Sum of squares. Use the identity alpha squared plus beta squared equals open bracket alpha plus beta close bracket squared minus 2 alpha beta. We know alpha plus beta is 5/2. We know alpha beta is 3/2. So substitute these values. Open bracket 5/2 close bracket squared minus 2 times open bracket 3/2 close bracket. 5/2 squared is 25/4. 2 times 3/2 is 3. So we have 25/4 minus 3. To subtract, write 3 as 12/4. 25/4 minus 12/4 equals 13/4. 13/4 is 3.25. The answer is alpha squared plus beta squared equals 3.25. See how we did not need to find alpha and beta individually. That is the power of these formulas. Let us try example 5. Forming a quadratic equation, find the quadratic equation whose roots are 3 and -4. Step 1. Find sum and product. Sum, let us call it S, equals 3 plus -4. This equals -1. Product, let us call it P, equals 3 times -4. This equals -12. Step 2. Use the formula x squared minus s, x plus p equals 0. Substitute s and p, x squared minus open bracket -1 close bracket, x plus open bracket -12 close bracket equals 0. Minus -1 becomes +1, plus -12 becomes -12. So the equation is x squared plus x minus 12 equals 0. The answer is x squared plus x minus 12 equals 0. This is how you work backwards from roots to an equation. Now, I want to warn you about common mistakes students make. Section 6. Mistake number 1. Sign errors in sum of roots. Some students write alpha plus beta equals b divided by a. Correction. Remember, the negative sign belongs to the sum. It is -b divided by a. Mistake number 2, completing the square. Some students forget to divide by a first if a is not equal to 1. Correction, always make the coefficient of x squared equal to 1 before completing the square. Mistake number 3, turning point signs. In a times open bracket x minus h close bracket squared plus k, the x coordinate is h. If the bracket is open bracket x plus 3 close bracket, then h is -3, not 3. Correction, change the sign inside the bracket to find h. Mistake number 4, max or min confusion. Some students think a greater than 0 gives a maximum. Correction, a greater than 0 is a smile, so it is a minimum. A less than 0 is a frown, so it is a maximum. Mistake number 5, symmetric functions. Some students try to solve for alpha and beta individually when asked for alpha squared plus beta squared. Correction, this wastes time and introduces errors. Use the identities. Now it is time for class evaluation. Section 7. I want you to pause the video and solve these in your notebook. Question 1. Solve x squared minus 10x plus 21 equals 0 by completing the square. Question 2. Find the coordinates of the turning point of y equals x squared plus 4x plus 7. Question 3. State whether the turning point in question 2 is a maximum or minimum. Question 4. If alpha and beta are roots of x squared minus 6x plus 8 equals 0, find 1 over alpha plus 1 over beta. Question 5. Write down the line of symmetry for f of x equals 3x squared minus 12x. Take your time. Write down your steps. Do not rush. I will wait for you. For your assignment, Section 8, please do these at home. Question 1. Express 3x squared minus 12x plus 5 in the form of times open bracket x minus h close bracket squared plus k. Question 2. Find the maximum value of the function f of x equals negative 2x squared plus 8x minus 3. Question 3. The roots of x squared plus px plus q equals 0 are alpha and beta. If alpha plus beta equals 4 and alpha beta equals 3, find the values of p and q. Question 4. Without solving the equation 2x squared minus 3x minus 5 equals 0, find the value of alpha cubed plus beta cubed. Hence, alpha cubed plus beta cubed equals open bracket alpha plus beta close bracket cubed minus 3 alpha beta times open bracket alpha plus beta close bracket. Question 5. Find the quadratic equation whose roots are 2 plus square root of 3 and 2 minus square root of 3. Let us do a summary of what we learned today. Section 9. A quadratic function is f of x equals x squared plus bx plus c. The graph is a parabola. Completing the square converts standard form to vertex form a times open bracket x minus h close bracket squared plus k. The turning point has coordinates open bracket hk close bracket x equals negative b divided by 2a y equals f of open bracket negative b divided by 2 a close bracket. Nature, a greater than 0 is minimum. A less than 0 is maximum. Sum of roots, alpha plus beta equals negative b divided by a product of roots. Alpha beta equals c divided by a. Symmetric functions. Use identities to find values like alpha squared plus beta squared without finding individual roots. Forming equations. X squared minus sum x plus product equals 0. I know this was a long lesson, but you have done amazingly well. Quadratic functions can be confusing because of the many steps, but you now have the tools to handle them. Remember, practice is the key. The more you practice completing the square and using the sum and product formulas, the faster you will become. If you enjoyed this video, please give it a like. It helps the channel grow. If you have not subscribed yet, please subscribe and turn on notifications. I post new lessons regularly. If you have any questions about this lesson, or if there's a specific problem you are stuck on, please comment down below. I try to answer as many as I can. And remember, for personal questions, my WhatsApp line is in the description box below. Do not hesitate to reach out. Thank you for watching. Keep practicing, stay confident, and I will see you in the next lesson. Goodbye for now.